it is summertime, and that means the return of fruit flies. I know they're in my kitchen plaguing my fruit basket, but they also plague farmers almost daily. Now a Minnesota startup, Novoclade, is developing a biological insect control system that sterilizes invasive pests, and they're taking their aim first at, you guessed it, fruit flies. Siba from Novoclade joins me now. Thanks so much for joining me, Siba.
Thank you.
Okay, so tell me what this is. You are targeting the spotted wing Drosophila, a fruit fly that damages berries and soft fruits. How are you doing? I know you're using genetic modification. Walk us through what you're doing.
Well, so the way we work is we provide some genetic modification, that goes into the system in their genes. And then during the rearing process, we remove that gene. So all we end up is a fly that is male. We kill the females in the rearing process. And then we take these males and then sterilize them with X-ray machine. And once they are sterile, we can release them in the field. So now because they are sterile, they cannot reproduce. They will mate with the wild females. Females will lay eggs, but those eggs will never hatch. And there is no need to spray pesticides, and you'll have perfect control over the flies.
Yeah, so what you're trying to do is alleviate the need to spray pesticides on these soft fruits,
right,
because farmers are obviously having to spray these pesticides to prevent from things like fruit flies. Unfortunately, there are other pests that plague these fruits. So, how do we ensure that the fruit is protected from more than just fruit flies?
Right. So this is a very specific control measure. We can target only one pest at a time. So we can. There are benefits to it because that way we are not killing the bees and the butterflies or any other beneficial insects. Because when you are spraying chemical, they are very broad range in their action. They can, cause damages to other insects. But in this case, you are only targeting one particular insect. That's maybe 80% of the problem the farmers are facing. So if you take out that insect, maybe they can go to reduced use of pesticides, or maybe we'll have an integrated pest management system where we can take them all holistically.
Are you hopeful to expand it beyond fruit flies?
Oh, of course, we are. This system can apply to any other insects. So, for example, in news, we have New World screwworm lately, and we just received a go-ahead from the USDA APHIS to start a program to use our technology on that.
I was going to bring up the screwworm because we talked about screwworm yesterday, and in screwworm they're using sterile fly release. So it's a sterile fly release program that sounds very similar to what you're doing, and they've been doing this since the 1960s with screwworm. How does it compare to what you're doing?
Well, what we are trying to do is we are trying to make the process much more efficient. So they have been releasing screwworms, both males and females. By releasing the females do nothing. They don't really contribute to the program, but they occupy space when they are releasing. What we are planning to do is we release only the males, and we are providing a means for them to be able to separate males only and they release the males. And that way it is much more efficient.
Okay, and you've actually received several grants to do this. The U.S. Department of Agriculture recently selected you as one of 40 projects, sharing $105 million to strengthen defenses against the New World screwworm, as you said. You've also received $1.6 million in National Science Foundation grants.
Yes, so that was for the spotted wing Drosophila work that we just talked about earlier.
And how did you get into this? How do you get into, let me get into genetically modifying insects.
Okay, so I was a scientist at the U before becoming an entrepreneur. And we have been thinking about how to reduce use of chemical pesticide for a long time. And I have been trained as a genetic engineer, a toxicologist. We know that because of my toxicology background, I know how difficult toxins are in system, and I have always been interested in reducing the impact of toxins. Well, we figured out a way to keep the genetically modified systems intact in insects and not be present in the released insects. So that's how we figured we could use it in insects first and sterilize the insect and bring that population down.
So I read that you're also possibly, hopefully at one point, will also take this technology to other pests like mice and snakes.
That's a long-term plan. We are talking with other funding agencies to help us, start a program with that. I'm not gonna name anything quite yet because it's not finalized. But yeah, that's the plan too. So DARPA recently announced a program for to tackle brown tree snakes in Guam, and possibly we might be able to help with that too.
And those are creating a problem there?
Yes, so these are so all we are trying to do is apply the technique to invasive organisms. Invasive organism meaning they did not belong here, and they came at a certain point of time because they don't have any native predators. They occupy space and they, create a much more problem. So in Guam, back in 40s or so, when due to shipping and such, the snakes hitchhiked and came to Guam and they decimated bird population there. So the forest birds are completely gone, almost gone. And they have been causing issues, so much environmental issues is that the government wanted to reduce that population down. They have been trying it really hard, but nothing is working.
Wow. So when you think about this genetically modified insect, do you release it like near the farm where the fruit is being grown? Or do you just release it into the general population and it works?
Right. So I just want to make it clear, the released insect is not genetically modified. So the released insect doesn't have any modification. The modification happens in the lab and stays in the lab. We will release them by the farm wherever the need is. And the insects, depending on the type of insect, they can travel a little bit or far. But they will, mostly what they look for is they want to find a mate and they want to find food. And the farm is a perfect place for them to find both those things. So they don't come to general population, for whatever reason.
Well, it sounds like a wonderful alternative for getting rid of our pesticides. More people are aware of what they're ingesting. More people are wanting to buy organic fruit. And berries and thin-skinned fruit like peaches and things are some of the most toxic fruits to eat when they've been sprayed by pesticides. So this seems like a great business to get into.
Yes, and that is precisely why we started the work on the spotted wing Drosophila. Spotted wing Drosophila, it's also an invasive insect, did not belong in the U.S. before 2008. Once it came in here, it started causing wide-scale problem for farmers. They had to just spray on, and even with that, they couldn't control this insect well.
Wow. Wow. Well, okay, Siba Das is with Novoclade. Again, they're a Minnesota startup, and the idea is that you're going to release sterile males into the environment, reduce pest populations, and hopefully reduce the use of pesticides at American farms. I appreciate you joining us.
Thank you so much. That's the hope we have. Thank you.
Great.